Example number 12. What is the pH when 25.0 milliliter 0.100 molarity sodium hydroxide solution is added to 15.0 milliliter 0.200 molarity hydrofluoric acid solution? The temperature is 25.0 degrees Celsius. Ka of hydrofluoric acid is 6.8 times 10 to the negative 4. This is a summary of this problem. Let's look at the flowchart. The first step from the flowchart is to figure out how many solutes in the solution. We have a sodium hydroxide and hydrofluoric acid. Therefore, there are two solutes in the solution. The next question we need to answer is, are the solutes react with each other? Sodium hydroxide is a base. Hydrofluoric acid is an acid. Acid will react with the base. So the answer is yes. If the solutes do react with each other, we have to use stoichiometry to figure out what chemicals in the final solution after the reaction. We also need to calculate how much of each chemical we have in the solution after the reaction. Then we go back to the beginning of this chart. Unfortunately, this process will take a while to finish. For stoichiometry calculations, we need a balanced chemical equation. To solve stoichiometry calculation problems, we want to organize the information of each chemical just below the chemical under the chemical equation. We are provided the information of both reactants. Therefore, this is the limiting reactant type of calculation problem. According to the balanced chemical equation, sodium hydroxide will react with hydrofluoric acid according to 1 to 1 moles ratio. Because we have more moles of hydrofluoric acid, sodium hydroxide should be the limiting reactant. Therefore, we should not have any sodium hydroxide after the reaction. We should have hydrofluoric acid left after the reaction. From the chemical reaction, we should produce some sodium fluoride. Because sodium fluoride is a strong electrolyte, it will dissociate in water. We can see that fluoride is the conjugated base of hydrofluoric acid. Let's calculate how much sodium fluoride in the solution after the reaction, according to the balanced chemical equation. Our calculation should be based on the limiting reactant. After the reaction, we have 0.0005 moles of hydrofluoric acid and 0.0025 moles of sodium fluoride. According to the flow chart, we need to go back to the beginning of the chart, which is here. In the final solution, we have a sodium fluoride and hydrofluoric acid. Therefore, we have two solutes. We will follow here. Sodium fluoride and hydrofluoric acid will not react. Hydrofluoric acid is the conjugated acid of fluoride. So we will follow equation 7 to calculate the pH of the solution. Now we know the moles of hydrofluoric acid and the moles of sodium fluoride. We need to calculate the concentrations of each. And the total volume of the final solution is the sum of the two volumes. Now let's plug the values into this equation. Generally, for a mixture of the conjugated acid and conjugated base, we can use the initial concentrations as the equilibrium concentrations. We cannot use the initial concentrations to replace the equilibrium concentrations if the ratios of the two is too big, like 100 times difference. Otherwise, we can use them safely. The final answer for this problem is the pH is equal to 3.87. Can you follow my example to work out this problem by yourself?